any number raised to 0 is just 1. So now I have 0 equals 2 plus c. In order for 2 plus c to be equal to 0, c has to be negative 2. So I would have 2 plus negative 2, or 2 minus 2, would equal 0. So I found my c value. Final step, plug c back into the general solution to get my particulars. So now I have y equals 2 plus, but c is negative 2, so plus negative is the same thing as minus. So 2 minus 2e to the x to the 5th over 5. Okay. So there we have that. Number 6 is very similar. It involves this whole ln deal and absolute value. All right, so again, we have a separable equation, so separate variables. So I'm going to have dy over y minus 1 is equal to dx over x squared. Okay, and then we're going to integrate both sides. Again, you can think of dy over y minus 1 the same thing as 1 over y minus 1 dy. And then on the left, or I'm sorry, the right-hand side, dx over x squared is the same thing as 1 over x squared dx. The integral of 1 over y minus 1 is the absolute, or ln of the absolute value of y minus 1 plus some c equals, on the right-hand side, we can use reverse power rule because 1 over x squared is the same thing as x to the negative 2. So if we increase our exponent by 1 and divide our current coefficient by our new exponent, we end up getting negative 1 over x plus c. Okay. Now we have to exponentiate both sides to get rid of the ln, but we've already seen up here that when you exponentiate the left-hand side, e raised to ln completely cancels out. So I'm just going to go ahead and write absolute value of y minus 1 on the left. Then when I exponentiate the right-hand side of e raised to the negative 1 over x times e to the c. I just kind of skipped this step that we did up here where we had both of them in the numerator, and then using the exponent rules, then you can split it up into multiplying powers with the same base. Okay. So now I have e raised to the negative 1 over x times e to the c. But again, this e raised to the c is just another constant that I'm going to call c, which means I have to go back and put a subscript on the previous c's. So absolute value of y minus 1 equals c e to the negative 1 over x. Now, I'm going to go back up here and I'm going to drop the absolute value. When I drop it, add plus or minus to the right-hand side. So plus or minus ce to the negative 1 over x. Ce to the negative 1 over x. Just like in the previous problem, that plus or minus c, the plus or minus gets absorbed. So I'm going to call that whole new thing c, which means I have to go back and put a subscript of 2 on my other c's. So now I have y minus 1 equals ce to the negative 1 over x. Finally, move my 1 over, so add 1 to both sides. So y equals ce to the negative 1 over x plus 1. Okay. Or you can write 1 or I'll write both, y equals 1 plus ce to the negative 1 over x. Either one works. For your general solution, then use your initial condition that f of 2 equals 0. So plug 0 in for y. So y equals 1 plus c e to the negative 1 over 2. E to the negative 1/2 is the same thing as 1 over the square root of e. Okay, looks a little funny, but I'm still trying to find out what c is. So I can move 1 to the other side. So I have negative 1 equals c over the square root of e. We know that a number divided by itself is equal to 1, but I want c divided by the square root of e to equal negative 1, which means that c has to equal negative square root of e. Okay. Then I can use my value for c to plug it back into either one of these general solutions that we found. I think I'll use the first one. I'm sorry, the second one. So I'll circle this one. That's the one I'm going to end up using. So now my particular solution based on this initial condition is y equals 1 minus square root of e times e to the negative 1 over x. Okay. Last question on these notes is more of a word problem about real world phenomena. It says the rate of change of the number of coyotes N of t in a population is directly proportional to 650 minus N of t, where t is the time in years. When t equals 0, the population is 300, and when t equals 2, the population has increased to 500. Find the population when t equals 3. Okay, so we have a lot going on here. Let's think about what they've told us. They gave us a couple of conditions. When t equals 0, the population is 300. So 0, 300 is one of our conditions. They also said when t equals 2, the population is 500. So 2, 500. And we're trying to find the population when t equals 3. So we're finding, in other sense, we're finding the population at 3. The population is represented by N of t, so we're looking for N of 3, population at 3 years. Okay. In the beginning, they also tell us that the rate of change of the number of coyotes, the rate of change of N of t, that's the same thing as the derivative. So I'm going to say the rate of change of coyotes we can represent as dn over dt, the derivative of n with respect to t. And they tell us that the rate of change in a population is directly proportional to 650 minus n of t. We have to use the proportionality constant, which is usually k, the constant of proportionality. So it says the rate of change of the number of coyotes is directly proportional, so k times 650 minus n.